Okay, so today we're going to use what we learned yesterday on the properties, proportions, and use some different properties to manipulate them in order to be able to do our assignment today. So yesterday we learned about the means extremes property. That told us that if I multiplied the extremes and I multiplied the means, I could cross multiply to solve a problem. There are a couple of other things that we can do with proportions. We can interchange the extremes or interchange the means and still have equal proportions. Okay, the plain old English of that is just trade their spaces. Like if this is my original problem, A is to B is C is to D, I can flip B and C, or I can flip A and D. So basically, I can swap positions in the proportion on the diagonal, and I still have an equal proportion. The reciprocals are equal, so here's my original problem. If I flip both proportions, I still have equal proportions. And if I take my proportions and I add the denominator to both the numerator and the denominator, I still have equal proportions. But the craziest one of all to me, if I have multiple ratios that are equal and I add all the numerators together and I add all the denominators together, I still have an equal ratio that's equivalent with the rest. Now I know this is a lot of jargon, but we're going to take a look at some practical examples. All right, so wait a minute. We like to have the cheat sheet. If I have EC is to AE and DB is to AD, then what would be equivalent here? Well, the only thing that's changed from this proportion to this one is I flipped my DB into the spot where AE is. So all I have to do is put AE into its spot, and I have an equal proportion. So let's look at another one. Using this same one, EC is to AE equals DB is to AD. Well, this time I'm multiplying AE times DE. Oh, no, I'm not using my same fraction. Sorry to mess you up. I don't know where my brain was when I wrote that example. I'm sorry, Garrett, so we're just going to scratch that one. Okay, take a look at this one. I have AC, which is the entire length, is to AE, as what is to AD. Well, you look at the relationship of AD and AE. They're both short parts of the longer side. So the longer side in this case would be AB. The last thing that you need to know in this particular section is what a geometric mean is. The geometric mean is when both of your values of your means are exactly the same. So if I wanted to find the geometric mean between 4 and 9, I would set up a proportion with 4 and 9 as the extremes. I would make x both of the means, and I'd cross multiply. When I have a quadratic equation, the opposite of squaring is taking the square root. The square root of 36 is 6, so the geometric mean between 4 and 9 is 6. Let's try another one. The geometric mean between 5 and 11. Since it's a geometric mean, these pieces are both the same. 5 times 11 is 55. Square root of x squared equals the square root of 55. We don't know what the square root of 55 is, so we just leave it like that. All right, assignment time.